Have you ever wondered how a beam of light can act like a wave one moment and a particle the next? Or how a single electron can pass through two openings at the same time? Welcome to the world where logic bends, certainty disappears, and probability becomes reality, the world of quantum mechanics. Welcome to the Learning Studio, and in today's episode from our physics playlist, we'll explore quantum mechanics and wave-particle duality. You can watch the complete physics playlist by clicking the link below in the description. This episode is part of our section Foundations, the Universe, Matter and Energy, the 12th subject in our whiteboard animation series, designed to make science visual, exciting, and unforgettable. The birth of quantum mechanics. At the beginning of the 20th century, scientists faced a mystery. Light, which was thought to be a wave, also behaved like a particle in certain experiments. And matter, which we thought was made of solid particles, sometimes behaved like waves. In 1905, Albert Einstein explained that light is made up of small packets of energy called photons. A few years later, Louis de Broglie proposed the bold idea that all matter, even electrons, also have wave-like properties. This was the birth of wave-particle duality, one of the most mind-bending and revolutionary concepts in all of physics. The Double-Slit Experiment, the heart of the mystery. Imagine firing tiny electrons one by one at a barrier with two narrow slits. If electrons were just particles, they should pass through one slit or the other, creating two bands on a screen behind. But what actually happens is astonishing. They form an interference pattern, just like waves. Even when sent one at a time, each electron behaves like a wave that passes through both slits simultaneously, interfering with itself, until it hits the screen as a single point. But here's the twist: the moment we observe which slit it goes through, the interference pattern disappears. The electron suddenly behaves like a particle again. Observation changes reality. The act of measuring a system collapses its wave-like possibilities into a single outcome. This is the core mystery of quantum mechanics. Nature doesn't decide what's real until it's observed. Quantum laws of nature. Quantum mechanics doesn't describe things in definite terms but in probabilities. It tells us where a particle might be, not exactly where it is. Instead of deterministic laws, the quantum world follows mathematical wave functions that describe all possible outcomes. When we observe the system, the wave function collapses, and one reality becomes real. This idea reshaped our understanding of nature. It led to Heisenberg's uncertainty principle, which tells us we can never know both the position and momentum of a particle precisely at the same time. And Schrödinger's equation, which mathematically describes how quantum states evolve, the heartbeat of quantum mechanics. The quantum world in everyday life. Though it sounds abstract, quantum mechanics defines much of our modern world. It powers lasers, transistors, semiconductors, magnetic resonance imaging, MRI, and even solar cells. Every computer chip and smartphone depends on quantum behavior. And in the future, it will drive quantum technologies, ultra-secure quantum communication, unimaginably fast quantum computers, and precision sensors. Quantum mechanics also bridges into the world of AI-based simulations. Scientists now use deep learning to model quantum systems that are too complex for traditional computation. AI helps simulate quantum states, predict molecular behavior, and design new materials at the atomic level, blending the boundaries of physics, mathematics, and machine intelligence. The strange beauty of the quantum world. Quantum mechanics teaches us that reality is not as straightforward as it seems. It's probabilistic, interconnected, and sometimes counterintuitive, yet deeply mathematical and precise. It's a reminder that at the smallest scales, the universe dances not to certainty, but to possibility. And understanding that dance allows us to harness the invisible rules that shape everything, from the flicker of light to the logic inside a quantum computer. This is the Learning Studio, and this was our episode on quantum mechanics and wave-particle duality. If this blew your mind, make sure to subscribe, like, and check out the physics playlist linked below. In our next episode, we'll move from the invisible quantum realm to the macroscopic world of thermodynamics and statistical physics, where energy, heat, and probability come together to explain the flow of the universe itself. Because the more we explore physics, the more we realize, reality is far more mysterious, and far more beautiful, than it appears.